And folks, usually I'll start with the agenda, and you know the drill with various slides, but this time I'm going to make an exception. We have a very special guest, Arno Schödl. I don't know if I butchering your last name, Arno. Sorry about it, but I do. Okay. I would like to present our speaker. It's an honor for me to have Arno. He's from ThinkCell. He's the founder and CTO. He's responsible for the design, architecture, and development of all of their software products. Oversees ThinkCell's R&D team, quality assurance, and customer care. Before founding ThinkCell, Arno worked at Microsoft Research and McKinsey. Arno studies computer science and management and hold a PhD from Georgia Institute of Technology with specialization in computer graphics. Welcome, Arno, to San Diego C Meetup. Very happy to have you here.
Thank you very much for the intro. Yeah, so I'm based pretty much the technical guy at ThinkCell. We do a lot of C++. We actually write an add-in for PowerPoint. Sounds pretty boring, but we have like this add-in on steroids with lots of complicated algorithms to do a lot of things automatically, and people like the user interface and so on. So, but that's all not the topic for today. Today, I want to talk about the practical approach to error handling. Now, when we started the company about 20 years ago, we had to think about, well, how do we want to handle errors in this project? And we had, well, some ideas about it, and we've refined them over the years, and that's going to be the topic of the day. Now, of course, errors can happen everywhere, and we all want very reliable programs, and we have absolutely no time to write error handling. So now, what do we do? First of all, before talking about the ways how to deal with the errors, I first want to talk about ways to transport errors out of functions. How do errors appear? How do they appear in our code? And how do we then have, so we understand how we have to handle them when they appear. Now, let's say you have a file and you want to open a file, and that file doesn't exist. Okay, so what happens? There are various ways to do it. One very basic way is the classic return value. You have a special open function, and that just returns whether this open succeeded or not. You can't use this for constructors. So if you have a constructor, you have to come up with something else. One way would be to have an out parameter that tells you whether the constructor succeeded. It's both not terribly elegant, and you would have to clutter your code with checks everywhere. And you, of course, can forget to check. For return values, you now, with C++20, I believe you have notice card that you can actually use to make sure that you always check your return values. You don't have such luxury with the out parameters. One option that I want to bring up for error handling is that's not that used that frequently is a status flag. It essentially would set a flag internally in the object if something goes wrong, and then at some point you can check that status flag. That has the advantage of creating only a single control path for basically the good and the bad case. And that's okay if the checking for your operation is at the very end is good enough. It's used often for writing a file because there it only matters whether all your write basically succeeded. For reading a file, maybe not, because you want to get stuff from the file, and if the stuff is not there, then you have to do something special. It's actually what the maybe not so beloved C++ IO streams are doing by default. And I'm certainly not a big fan of C++ IO streams, but that's one aspect of them that's really not so bad. One place where this is also being used is for graphics operations. Often you are basically just issuing your graphics cards, commands, and then at the very end, once you've built your whole frame, it's essentially, okay, did this all succeed, or do we need to reset our state and start from scratch? The general idea of having a single control path for the error case and the success case is going to be something that's interesting for the talk. This goal is also part of the idea of using a monad to report errors. It's essentially like a variant, a state variant of the result or an error, and plus some utilities that basically helps you pass this object through your code, dealing or operating on the result, but kind of transporting out the error. And there was a proposal for C++, the state expected, and I think it is still making its way through the committee at the time. Now, the classic way, of course, to report errors are exceptions. And a few things that well, we should all know already. We will probably know already about exceptions. You always should catch them by reference. That will prevent slicing if you are sketching a base class. And it will also prevent copying, because if you're copying the exception, then if this copying itself goes wrong, then you would basically have a double exception, and that would terminate the program, which is certainly not something that you want. If you're writing code like below, where, well, we caught here by value, we should be catching by exception. If you then rethrow the exception with just throw a semicolon, just keep in mind that this actually throws the original exception. So it doesn't matter really how you caught it. It will always be the original one. Now, exceptions work a little bit like a multi-level return or a go-to. And they are kind of ugly in that way, that they add these invisible code paths to your code. And that's one reason why some code paths don't allow, some code bases don't allow exceptions. And that's why what makes these monads more attractive is when you're writing code like this, where you have a throw in a function, and then you call this function, and we require you to annotate here the throw, because this throw here will basically generate this escape hatch from that function, and that exception will reappear here. So if I'd be mean, it'd be like, okay, this is a little bit like writing code like this, where you have these go-tos here. You have this extra channel that leads you out of the function. And if you are throwing an exception, you're really filling the information in about this escape hatch, and then you leave the function in a special way. And then in the main function, you again treat that special. If you are using this escape channel, then you're checking if that escape channel was used, and again execute some extra code path to do the exception. That's kind of ugly, and of course I have to stop whining, because everyone teaches to write exception-safe code. Now, let's see, before we talk about whether we can do that and how practical that is, let's take first a look at what it means to write exception-safe code. And what I'm talking about here is not really exception specific. It's really it could be any kind of error, and it's part of a function specification, of an operation specification. Now, the best thing that we can aim for is an operation that never fails, and that'd be beautiful if all the operations would be like that. Then we wouldn't need to worry about error handling. That's often well, it's difficult to achieve, or impossible to achieve for some operations, like opening a file. You cannot really guarantee it's there. Now, the next best thing you can have is this strong exception guarantee. That means this actually may fail or throw, but if it does, then it will restore the program state to whatever it was before. So it's transactional. Either that operation takes place with all the side effects, or it basically rolls back everything when you have the previous state. And that's certainly possible and desirable in whatever, in library functions, in small operations in your code. In application code, this is very hard to achieve, because very frequently you have many state changes in a long sequence, and to roll them all back would require considerable additional infrastructure, which you would have to maintain and you have to write and you have to carry around in your code, load to your program. That's usually very difficult. Now, there is some middle ground, which is the basic exception guarantee. There, it may fail or throw, but it will just restore the program to some valid state. Now, what's a valid state? You could imagine having this conversation with your support department. So you are Microsoft support and it's, hello, this is Microsoft support. I was writing a book and suddenly Word deleted everything. And then you would say as Microsoft support, okay, that's fine, because Word only has basic exception guarantee, right? And an empty document is a valid state. And the customer says, oh, it's only basic exception guarantee. Well, that's fine then. And I'm very happy that you told me that. And I thank you very much. You have a good day. Well, of course, that conversation is never going to happen. What my point here is that this basic exception guarantee is very nice theoretically, but it doesn't really buy you much. Because the customer wants to get work done and he doesn't want to deal with errors. Now, so here's the problem. Error handling is a lot of effort. In development, you have to be very paranoid, and then it creates a lot of extra code if you want to, especially if you want to make it do it well and you want to provide strong guarantees. Now, in testing, you have these many code paths that you have to test. And as we all know, if you don't test these code paths, they won't work. So it's a lot of effort. And at the end, there's very little customer gain because the customer wants to get work done. He doesn't want to deal with errors. And any error that happens is just going to annoy him, no matter how much effort you put into handling this error really well. So what do we do? And what I'm going to talk about is what we did at ThinkCell to solve that dilemma. So here's what we do. First of all, we check everything. We check every API call. Every API call you do, if it has some means to report some error, and most of them do, you have some sort of wrapper that checks whether these API calls succeeded. So there's like for Windows, you have get last error, you have H results for com calls. For Unix, you have Arno, Linux. You assert aggressively in your code. We let these asserts stay in release to make sure that the program works and that it stays what I'm calling on this narrow path of correctness. That it doesn't deviate from that. We try to keep the number of control paths small. We also try to keep the range of states in the program small. We want to keep the state to be very well described and not have these special situations crop up in the state of your program. So we assert aggressively. If the caller is not prepared to handle an exception, all the functions, we make all these functions no except. Yes, we will still terminate if there's an unexpected exception, but probably if you don't catch the exception, your program will probably terminate anyway, and it will be undefined. Now, we can install a handler that's again with this checking everything. You can install a handler for set terminate that makes sure that doesn't happen and that you would know about this to terminate to happen. And after you did all that, after you checked everything, you assume that everything works. And this is important because you don't want to create all these code paths. You don't want to create all this complexity. Just check, and then you assume you're good. Now, here again, the goal is keep the set of code paths small and keep the set of allowed program states small. So make things simple for yourself. Now, what do you do if these checks fail? Now, of course, you need to understand what the problem is. So the priority number one, if these checks fail, is not to keep the program running, is not to keep the customer happy. That's not the priority. Priority is for you to collect as much information as you can to fix the problem, to actually now decide what am I going to do. So the client, if you have client, the desktop application, you will send a report with a memory dump home. And by the way, if you have any questions, just put them into the chat, and I'll once in a while I glance over to the chat and I'll answer your questions as I go. So when you have a desktop application, we send the report home with as much information as we can. If we have a server, we actually have the best debugging environment that you can imagine. We have the actual program. So we hold the thread and we call the operator. And hopefully you can attach with the debugger and find out what's going on wrong on the server, what's going on the server. Now, priority number 2 then is to carry on somehow. Now, if the check that failed is critical, which it usually is with the examples that I gave you, you usually want to do something with the API call that you need for your program, and for the assertion, it certainly that defines what that defines the good paths. And if that fails, then well, something's wrong. Now, the program behavior will then, from that point onwards, be undefined. You don't want any further reports because it's likely just going to be fallout of your previous report. Now, you don't want to terminate the program if an assertion fails or if something goes wrong, because in particular, assertions can be wrong as well. People may write wrong asserts, and you don't want to punish them for writing wrong asserts, because aggressive asserts will help with the correctness of your program. You don't want to punish the developers for writing them and for making a mistake. So you just carry on if the assertion fails. Now, people may say, well, what about security? Like, can't that lead to bad things? Well, it may, but if you need safety, like you are controlling a nuclear power plant, then you need to add this safety at a higher level. So you need to basically monitor whatever your parameters of your nuclear power plant are, and you have to scram the control rods if something goes wrong. Now, we do something with a server that's similar. I said we're going to hold the thread, right? Because priority number 1 is to collect information. Now, what if we basically halted all the threads and now the server stops? Well, if you think about it, that's not really that special, that situation of halting a thread, because you may also run into an infinite loop somewhere because of a programming error, right? So, and an infinite loop, for all practical purposes, is just like halting the thread. Now, if you want to keep your server running, one thing you can do, which is what we do, is we say we have several request categories that the server processes. And if you are running with your one of these categories into some sort of thread limit, then you'll stop processing these requests. So once my, I don't know, processing credit card payments thread, and that will be a bad one, runs into, has eaten up all the threads, then I'm going to stop handling credit card requests. But maybe some other function on my server will still work, and will still continue to work until I've actually found out what's wrong with my credit card processing. So that's one way, basically, how to contain this problem on the server. Now, the next step is, you'd say, well, maybe we should start write error handling code now. Well, I would say no. First, reproduce the error at home. First, try to understand the error, reproduce it in your code, and know how it comes about. If you don't do that, you will just add error handling codes for error handlers that are either never used because you added them in the wrong place, and they are never tested. Because you don't know how to reproduce the problem, and you don't really know whether your error handling actually error is actually appropriate for the problem that you wrote that handler for. Now, experience is, of course, 5% of the handlers handle 95% of the errors. So you need to write very few handlers that way. Most API calls just never fail. And if you're writing error handling codes for all these API calls that never fail, you've wasted a lot of effort. And that's exactly what we try to avoid. So that's why we have this evidence-based way of handling errors. We just handle the ones that actually occur in the wild. And so of course, what you have to do is you have to send information home about the error. So you need some way to report and send things back to you. Now, I classified here categories of errors. So far, we talked about critical errors, and these are basically the ones where the program behavior, well, the program is broken when if they occur. So an example would be a null pointer access, or an API call where you don't have any way to handle the problem, or at least where you don't expect this particular error code. So even if we expect an API call to fail, we usually provide a list of error codes that are permissible, and some others are not. So if maybe you wouldn't expect an invalid parameters because, well, you passed the right parameters, so you would expect this not to be the case, not to be an error that's permissible. And also assertions that fail, they are certainly critical. And they are treated like never happens. They are treated like we don't write handlers for these errors. And we also treat the program as basically, as the program behavior as undefined, a little bit like C++ undefined behavior. The program is invalid if such a condition occurs. Now, what do we do? As I said, we send the report to the client, from the client to the server, and then we disable all future reports. And these reports are actually processed by a server in our company, and they are automatically classified and made available for the developers. Now, for the server, you can actually hold the thread. That's a nice way you can debug them. Now, should you tell the user that this condition occurs? Well, again, you don't want to punish developers for writing wrong assertions. So only notify the user if you're really sure that things are going to go south from now on. So if you are doing a null pointer access and basically the program is about to crash anyway, yes, by all means, tell the user. But for example, for assertions, we don't tell anyone because maybe the assertion was just simply wrong. And there is a substantial number of assertions which are wrong and that are fixed, I would say maybe 10, 20% that are simply fixed by removing the assert or weakening the assert typically. Now, there are several more categories of errors that are also worth pointing out and that are actually also reported for us. Now, one of them, or one level down from basically a critical error, is that you have something untested. Here's an example. Say you have in your host application, you have some sort of foos that are being registered with the operating system. So you have a register foo function, and you want to know about all these foos that it's registering with the operating system. So you have a hook for that registering foos function in the operating system that keeps track of foos as well for you privately. So this will basically look like this. You're getting a foo, you register the foo with the operating system, and if that registration worked, if that succeeded, you keep track of these foos yourself. So you know that, okay, this foo is now known to the operating system. Now, the operating system says there was an error, right? It wasn't basically you who triggered the registration. It was that host application that you are monitoring. And so if there was a problem with the registration, maybe there was a bad foo, then, well, you don't need to keep track of anything because there's nothing being tracked. So, okay. But maybe you've never seen that register foo failing. So it never happened in your tests. The application never produced a foo that wouldn't work with the register foo operating system function. Now, if suddenly this register foo somewhere out in the wild where you cannot really keep an eye on it, starts failing, that would certainly be interesting to know because, I mean, maybe the host program cannot really deal with failed foos, with failed register foos. So this is one of these situations where we also send a report and basically with the goal of finding a reproduction where you say, okay, this is a condition that actually occurs. It's not really critical. Theoretically, we should be okay with it, but maybe funny things happen down the road with our environment that we would like to, well, that that we would at least like to keep an eye on. Now, in debug, you certainly have to notify the developer if something like this happens, because if it's running like during your testing, or if that happens during your testing, or even if the developer is just running the program on the developer machine, you certainly want the developer to know, because you just found a reproduction, and then this is no longer untested. This is something you can actually reproduce. Now for the server, similarly, you also want to send a report because you've got a reproduction. Now, even one more level down, there may be third-party bugs. So let's say we are running in the context of PowerPoint, and PowerPoint sometimes makes shapes disappear. Now, that's not nice, but we know that it actually happens, and we know that the program state is okay, that we can deal with the situation, and we've tested it, and it's all good, but certainly the user is going to be unhappy. Now, there may be situations where you don't want to work around everything. If the condition is sufficiently rare, you may not have a good solution for your user, and you just say, "Oh, it's a bit ugly, but still, I'm going to leave it at that." That may be a reasonable decision. Now, if that's what you want, then at least you should log the problem, because there are going to be people, customers, who call and say, well, there's this condition that occurred, which my shapes disappeared, and I'm not happy about it. And then you can look into the log and make sure that this is actually the condition that you know about, where it's like, oh, okay, yeah, you ran into that bug of PowerPoint that makes shapes disappear. Now, if you have that, then you have the log, you can take a look, then you can, first of all, you can explain it to him, and also that informs your decision whether you should actually produce a proper workaround for that situation. There's another level of error, even more level down, that kind of ordered in the sequence of severity, where you have some indication that you have a bad environment. For example, you see already an add-in that already hooked the same function that you also hooked, which the program you supports. We can deal with it, it's okay. But maybe this other add-in is not so happy about it. It may malfunction if you hook the same function as it does. Another situation would be, let's say the operating system reports some funky character as a decimal separator. So a space, for example, which you usually wouldn't have. And again, your application may be happy with it, it may be tested and it's okay, but maybe that special decimal separator will cause other problems in your host. So maybe you kind of want to know that this special situation occurs, because it could still cause some problem. Now, if this happens during a remote support call, then so you are basically attached to the customer machine, the customer is showing you some problem, which is something that we do, then you certainly want to pop up something so that the person who is doing the report, the support session knows, okay, there's this special condition, and maybe the problem that the customer is going to show me has something to do with that special condition. Now, here's what we do when we send these errors, we send these reports home. These memory dumps, this information that we collected, basically the local stack space, registered contents, a little bit knowledge about the environment, about what modules are being loaded and so on, they are being sent to the server. That happens automatically if the user opted in. If the user opted out, then the user is being offered to send a prepared email where you can send that report. And all these reports then end up in a database. The memory dump is automatically opened in a debugger. And we basically categorize the error that by the file in the line where it occurred. And then you essentially have a long list of errors where for each error you have occurrences. These are basically the reports that came from the same line of code. They're all put into one bucket. And so for each of these errors, you have several occurrences, and you can double click on the occurrence, and it will open the mini dump, the stack the stack dump in a debugger for the developer to look at. Now, we also wrote, and it's in our GitHub repository, a similar facility for Mac. So we actually, it's a little LLDB compatible dump that we generate, but that's not as large as a full dump, because that you wouldn't be able to transmit. Now, our developers can mark errors as fixed. So these categories can be marked up as, from this version onwards, this error shouldn't really occur anymore. If it does, then it's essentially caused or treated as a new error, because it should be fixed. So if it still occurs, then we should flag it again as not fixed. But if it happens to be fixed, so if you receive a report from an older version that has that error, you can trigger an automatic update. You can automatically send them the new version of your application. And we've done this for the automatic reports, but later on we also did it for these emails where people, if they have opted out of error reporting, these emails that we prepare for them, and that borders magic, because people, they are aware, they write an email to support, and 5 seconds later they receive an answer back, yes, your problem is solved. You just have to go download that new version. So in the beginning, when we introduced that, people were quite surprised. Now, I want to talk a little bit more about what you can do about cause analysis, and it's going to be a little bit more theoretical. So very often the problem is related to the customer environment. And well, why is that? Well, otherwise the in-house testing would probably find it already. So there's quite frequently if you have some errors, it's something wrong with the customer machine. And if you have a desktop application, as we do, you just don't have any control about the environment. It's just something that you have to live with. That you are not so that you don't have that much control. Now. And it would be awfully nice if, from the information that we receive from the machines, we could narrow down what the problem may be. And quite often that problem has to do with some third-party software that's running on that machine. And the memory dumps have a list of loaded modules. And these third-party other add-ins or maybe some virus scanners or whatever people have on their machine, they often have some modules that identify them in the process space. Now, can we identify which one of these modules is causing the error purely by statistics? So we are trying. Let's say you have that report database that I talked about, and all these reports are stored in that database. Now, some of the reports are the problem that you're currently looking at, and the other reports we can kind of use as background distribution, as background reports of machines that don't have that problem. They have a different problem, but not that problem. So we'll treat that as kind of the background. So let's say here, for an example, you have 12 error reports in your database, and one means this report is about this particular problem that you're chasing, and 0 is a different problem. This is not that problem. So 6 occurrences in your database among 12 reports have the problem. That would give you this binary string of 0s and 1s that indicate which reports have the problem. Now, in addition, you have the information which machine where this report occurred had which modules. And so here the X says it has basically the first line that it has module A, certain machines when they in the report module A, and some other machines report module B. And as you can see here, module A is uncorrelated. So you have 3 of the machines of the ones that have that problem have 3 out of 6 have the module A in the problem case, and in the background case, it's also 3 out of 6. So pretty naively, you could look at this and it's like, well, module A is not going to be it. But let's say there's also module B, which is a bit overrepresented in the machines which have the problem with 4 out of 6 versus 2 out of 6. Now, And keep in mind, we want to find the most likely source of the problem. So it's not going to be that this module B may be present in all the situations where you have this error, because there may be multiple problems that cause the same error, and you basically just want to find the frequent one, your best chance, and then you're going to address it, and then you will carry on basically with a long tail of other possible causes, which would turn into other possible modules. So you have one module B that's overrepresented among the reports of your problem. Now, question would be, is this module B responsible? Or is it just chance that module B is overrepresented? And this is not so easy to answer. I mean, if you have only 2 modules, that's okay. But if you have, 200 modules, and you have many different versions of these modules occurring out there, where some version range of these modules may be responsible for the problem. So, there's some add-in that started to be bad, starting with version 7. It's just not so easy anymore. And if you have enough hypotheses to test, it's not something you can do you may also find some correlations just by chance, and we have to weed them out. We have to find out which are the ones that are really statistically significant. Now, one way to do this would be minimum description length, which we're doing. The idea is, let's say you have that, again, this bit vector that you want to compress, and it has 6 ones out of 12 occurrences. These are the reports. How often does my error occur per report? And you have 12 reports, and 6 of them have this particular error. You would have that binary string to compress, to explain. Essentially, compression always has to do with explaining. So you'd have to explain how does this, you encode the string, and by encoding it, you explain it. Now, if the module B has something to do with the problem, certainly knowing if your particular machine that sent that report has module B should help you predict whether that machine is reporting your problem, the problem you're currently looking at, because you're saying module B is kind of causing the problems, correlated with your problem. So knowing whether module B is present should help you with compression. So you have basically then different statistics on the machines that have module B and the ones that don't have module B with respect to the occurrence of your error. Now, you can do that. We use arithmetic compression. It's the Laplacian estimator, which estimates the probability that the report contains a particular problem. And initially, it assumes that all the probabilities that a report has a particular problem, that they are equally likely. And it then tries over time to adjust this probability to learn basically how frequent is my problem. And here are the number of bits that it then requires to encode K times I have the problem out of n reports. And it's this formula. And if you look at it, it's not so surprising that it's the way it is. So this n+1 here is really, you have to choose how often my problem occurs. And we said all the P here are equally likely. So you are first basically choosing, okay, how many, if I'm receiving 37 reports, how many of them actually have the problem? And then this encodes how many combinations there are. If I'm deciding, okay, it's 12 out of these 37, this is the number of combinations to choose 12 out of 37. And then you have to encode all that, and that produces this logarithm. Now, if the number of bits becomes smaller, if your probability is closer to 0 or 1. So if you are, then it's better to compress. So if you have 12 bits and you have to encode 6 ones out of these 12 bits, it actually costs you 13.55 bits. It doesn't only cost you 12 bits because the 12 bits kind of assume that your probability is 1/2. If you know a priori that it's all equally likely, then you would say, yeah, it's 12 bits, right? You just compress a bit with a bit, and then the 12 bits become 1 bit. And if the probability is 0.5, you can't really do anything. You can't do any better. But here we are trying to. So we say all the p's are equally likely. If the probability is that you get this error is really small, and you don't have the 12 bits have no ones at all, you can actually encode that in 3.7 bits. So if the p is closer to 0 or 1, the number of bits gets smaller. So let's do this compression in the context of having a particular module. So first of all, if you press all the reports together and you got 6 out of 12, these are again these 13.55 bits that you need. Now, if you do this in the context of module A, so saying the statistics are separate in the presence of module A versus without the module A, then you essentially have 6 out of these 12 modules that you compress separately, and 3 have this problem. So you have to compress 3 bits, 3 ones in 6 bits. That costs you 7.13 bits, and it's just calculated according to the formula on the previous slide. Now, and you also have the reports without the A, that you count as a separate statistics, and you again need 7.13 bits. Not surprisingly, doing this compression separately doesn't help, right? Because in reality, we have the same statistics with or without A. So in total, you get 15.26 bits. And this module A has nothing to do with the problem. I think I left out that there is, you need 1 bit to choose module A over B. And this is something that you cannot ignore. So if you want to send this really to someone else, and this is the game we're playing here, we're writing a compression algorithm essentially, you would have to say a priori, well, I want to choose module A to create different statistics. And this is really your hypothesis. This is really where you're saying, well, module A has something to do with the problem. And you say that by dividing up the statistics for all the reports with A versus all the ones without A. Now, you can do this with module B as well. And this is where it becomes more interesting. So now we are compressing all the reports with B separately. And we got 4 ones out of 6. So that takes us 6.71 bits. That's better than the 713 we had before. But if we do the math, it's 14.43 bits, which is still worse than the 13.55. So we can say that module B has nothing to do with the problem. This may very well be chance that we got these statistics here. Now, if you add a module C that has an even bigger bias towards occurring together with the problem, say in 5 out of 6 cases, if you look at the module C being present, then you see the problem 5 out of 6 cases versus only 1 out of 6 cases if module C is not present. The math gets more favorable. So first of all, you now have to choose 3 modules between 3 modules. So you have to choose the module C over A and B. And you need basically log2 of 3 bits to encode this. That's this number. And then you do again the compression like before, and you get 5.39 bits each time. Now the total is actually lower than your 13.55 bits, and that would actually tell you that the module C is actually relevant for this problem. And if you add more hypotheses, then, as I said, chance just becomes more likely. That's why we have to go through this mechanism. We can't just, ignore the number of hypotheses altogether. This information here that we have to account for is crucial. And in particular, these number of hypotheses gets much larger if you extend it to to module versions. So if you have many more hypotheses. And it actually, the system also works, it will produce the same results. So if a certain module fixes the problem, because that also gives you separate statistics. So if there's one module that really stands out, if that's present, the problem never occurs. You'll just find that as well, just by, you don't have to do anything about it. It will just give you that answer. So if you are if some particular module stands out, it's useful to have the information, which is easy to produce. Is that particular module that you found, is that particularly bad? And it makes the problem occur more often, or is it actually good? And it actually suppresses the problem. Okay, I'm coming almost to the end of the talk. I want to talk briefly about C++20 contracts. They are a new language feature in the realm of error reporting. It's essentially an assert on steroids, where you can make a declarative function preconditions and postconditions, and with a special syntax. Now, not surprisingly, there is a lot of debate about the details. I already talked about all these error categories and how we report, and what to do if you run into a problem, whether to terminate or not. So they discuss that. So they say, okay, when should we check the contract? Should we check the contract if in debug, in release? Shouldn't we do it? Never. And what should we do if the contract is violated? Should we terminate? Well, maybe not most of the time. Should we carry on? And how should we do a report? And to whom? And which information should we report? And how should we collect this information? So there are many questions about this feature that made it be removed from C++20 at the last moment. And certainly this discussion will continue for C++23. Someone is asking, or you can read it yourself, have you done a machine learning model for the isolation of third-party software problems? Well, this is kind of what this is, right? I mean, we only have very limited information. I think possibly, I don't think we have the data to train some more advanced model. I mean, I guess you could try to get even more information about this from these dumps, and do some more advanced classification. It wouldn't be really clear what the input is. So the best structured input we have are these modules, and I'm not sure that using raw memory content or anything like that for classifying problems would actually help. This was basically the low-hanging fruit that we used, because this is something that we actually did already manually, by sampling occurrences. People went through the database and said, oh yeah, okay, we see this version here and we see that version there, and then our support said, well, that's really tedious. We don't want to do this manually, and there are so many modules to check. We can't really guarantee that this is something that's we can actually do, and that we're not going to overlook anything. And then someone sat down and maybe they were a little bit math crazy, and they came up with this very rigorous way to do this analysis. And now it's basically whenever we open the bug database, we already get the information straight away. Which module may actually have to do with the problem. And so no one has to sit down anymore, which is good. Okay, that was basically the talk. Thank you very much for attending. And yes, we are recruiting hr@thinkcell.com, even if you are far away. I'm going to tell you this. Okay, so any questions, any comments, anything you'd like to discuss?
Thank you, Arno. I have a quick question. So usually I think users would need to consent, to have a consent that they allow you to push data back to the server. Do you have majority of the people saying yes to this option, or like opting?
Yes, we do. I mean, and we do. I think we do check it by default. So we play this little trick maybe, so that basically there's a checkbox, and people do have to consent to it, but we make it easy for them to consent, and we do get many reports. So that's yeah. We just have to, we have this checkbox in a prominent place, so that's not that And to be honest, we never seen any customer data in these stack traces. We've never seen anything where we would have even the slightest clue what the slide looks like that they're currently looking at or anything like that. So I've never seen anything. Okay,
thank you. Great talk. Thank you so much. Is there anyone with more questions? Please chime in.
If there's time. Arno, are you concerned about the impact on performance by leaving the asserts in, or do you try to categorize those that are for release versus development?
So we keep them all in by default. We selectively take them out if profiling shows that it's a problem. So by default they're all in. Developers don't really think about it when they're writing the assert, whether that has a performance impact. We actually did something which very recently, which I haven't discussed here in the talk, to quite low level and technical, to improve the performance of these reports. What we did is we created we basically, when you have this assertion, there are always these parameters being passed about the assertion, right? You have to pass the source location, and maybe there is the text that you want that you asserted. So the condition that you checked in the assert, and most of these. Most of that information is constant for this particular assert. So essentially, it would be an assert calling your reporting function with a bunch of constants. And it turned out that, of course, if you put these asserts then into the code, generating these parameters is costly. It costs you room in your code, and the compiler has to generate code at the call site. Now, if you think about it, really, the assertion contains constant information. So the best possible assert would be one where you check the condition and then just do a parameterless call without any arguments to a particular function that then knows about all these parameters, so that you are and this reporting function can be, and we put that into a separate code section, so that you essentially have your hot code section where your regular program is running, and whenever there is a condition failing, there is a simple parameterless call into a code section where that then augments this call with the parameters that you need. So there's basically just template instantiation, and it generates the constants that are needed. It generates the source location name, and it generates the actual assertion condition that you want to also send back to the server. Because all constant strings. So we currently have that in precisely to improve performance for asserts that stay in the code. So you have you generate a separate code section, and you're writing some template magic that makes sure that all these parameters, they are essentially passed as empty structs. That as templated structs, and these empty structs are essentially empty structs meaning a particular string constant, and then we, for actually Visual Studio, you need to optimize empty parameters, because otherwise it'll pass empty parameters regardless. It will generate, pushes garbage on the stack just to satisfy the calling convention. Clang doesn't do that, but Visual Studio does. So we actually have more template stuff that actually compresses these parameter lists, so that at the end you really, for a simple assert, you have a parameterless call into a code section, and there you have you basically expand your messages in order to keep the performance impact of your assertions as low as possible in the code. The very important is also that the assertion, and that also was a problem, must not interfere with inlining. So that if you're, for example, if you want to check an assertion condition, and that assertion condition may throw in an exception that suppressed inlining in the Visual Studio compiler. So we also had to play some tricks to minimize this problem. Basically you have to make sure your asserts that are efficient. And yes, you have to check the condition, obviously, but nothing else. You should really keep the extra code or all the cold code somewhere separately, so that improves performance.
Good idea. Thank you.
The remaining slides are about undefined behavior, and I didn't think that I think it's a bit of a different topic, and I didn't want to go through it. So, okay. But I mean, I'm sure you're all familiar with undefined behavior. So.
What is your thought about the static exceptions that being?
It'd be wonderful. I mean, I think if you ask me, this exception mechanism is really a different channel out of a function. You can use it for error handling, and certainly it's practical to use it for error handling and use it for that purpose. But if you think about it more generally, it's just another channel out of a function. And if you have this error handling or these exceptions that Herb Sutter, I think, was it proposed, right? Then it would be much cheaper to throw exceptions, and then you could use it for more places. One actual application is that we wanted to use, where we cannot use exceptions, is to stop iterations. So if you have a generator that generates data and you want to stop the iteration, you want to say, okay, the generator, you are okay. My sink is now happy. I don't need any more data. Then one way to do this is with a return value, to say, okay, please break your iteration. I'm done. But another way would be with an exception, which would probably be the right thing to do, where you just say, okay, I'm just bailing out of that generator. But you cannot do this all the time, because it's not, the performance is not good enough, and it certainly isn't. And there it would enormously help if we had faster exceptions.
Yeah, I think they call it as a joke, herbception.
Okay.
Thank you.
Yeah, maybe you have to take, you say you can also do that with semaphores. Maybe you have to take that offline. I don't see the connection right now. I think. Oh, you mean you can use exceptions for semaphores, or you can stop generators with semaphores.
Flow control.
Okay. Yeah, maybe you can take this offline.
Okay. And I think you have the slides on your website, right? So if someone wants to see the 4 remaining slides, they can. And I'll upload that. Can I also upload that, or I don't know?
Yeah, sure. Yeah.
Okay.
Yeah.
We have a Dropbox with all of this slide. Okay. Thank you. Thanks a bunch. Thank you so much. Great talk. I really enjoyed that.
Okay. Thanks very much for listening.
Good night.
Thank you very much. Thank you.
Thanks. Bye.
Okay, folks, really, if you want to stay here for another, I would say 45 minutes or so, please feel free to stay. I'm going to present a few things. So let me take a look. 1 second.
I'll stay connected for a bit more. Thank you for organizing this, Kobe.
Thank you. Okay, so usually I start with, I just didn't want to keep Arno awake. It's the middle of the night for him. I really appreciate his talk in such a very strange hour of his time zone. So again, thank you, Arno. And usually I start with the agenda. So the first thing was the error handling, and the regular stuff. We'll do some CPP quiz, some other things if things are gonna compile or not. And if we have time, I'll go over the 2 years of my C++ books recommendations. If not, we'll do it next time. And this meetup is sponsored by Qualcomm WRD Software, so thank you, Qualcomm. We have a Dropbox link now. When a new member is joining the meetup, there is a welcome message with all the links. This is something new that I think I started a few weeks ago. So if you're new, you probably seeing the new message, not the template, the regular template one. So I added some more things that be easier for people to find all kinds of information about the meetup. We have the YouTube channel that I'm uploading. Obviously, Martin's blog also has a link to our meetup. So thank you, Martin, for doing that. We have a Twitter account. I'm managing the Twitter account. This is the handle, and also my handle is Cppy_CA. You guys seeing my slides, right? Hopefully.
Yes,
Okay.
I can see it.
Okay. So this was a slide related to our talk that we just had. Next month would be my pleasure to have Andres Vertigo. He is the author of Cpp Insights.io. That most of you, if you're following me, you know that I'm a big fan of this tool. If you're not familiar with that, I can show a small example. He is the author of 2 published books on LeanPub, one related to C++ 20 and one on templates, and he would be presenting on templates at 9 a.m. And since he's again from Europe, if I'm not mistaken, Germany, in order to accommodate his time, we would do it on Saturday, the 12th, 9 a.m. Pacific time. Hopefully that would work for all of you, most of you. I know it's a Saturday time, but hopefully you can make it. I'll know from the invite and reservation, see how many can make it. So this is his bio. I'll probably repeat that after in the next session. So if you don't know what is Cpp Insight is, let me give you a small demo, because I really like this this tool. So Cpp Insight, Cpp Insight.io would give you this this window, and you can choose any of the standards from 98 all the way to 2A, basically 20, and you can have all kinds of other options. But if you just take the default, you can write your code here, and you can just click on the play, and it's going to just give you the data. So nothing interesting here. So I know this is very not interesting, but if you, let's say you have auto v equal 3.5. So what is auto? You can play and have this. Okay, it's a double. It's a double. This is what the type is, and you can even make things even more fancy. And let's say you have TT. And you can call a function f with let's say just play it. So And he would explain that, by the way, in this session. You can see that there is instantiation of f. So this is the template one, and this is the instantiation because I had unsigned long. So here you can see that it was deduced as unsigned long. And if I have something like this, and I want to explicitly say this is a U encoded to E and see what happens there, so you can click on that. So there are all kinds of buttons here that you can. First of all, you can share it with your friends. You can go back to Goldbolt, and Goldbolt has a link back to Cpp Insight, so you can have this cross site games, and it's super useful to say, hey, what is happening here? Like, what is the AST that is generated? So very nice. Very nice tool that I'm using frequently if I have any questions. So this is Cpp Insight. Let's go back to my slides. Okay, so we were here. Okay, so the next thing would be, let's play with Cpp Quiz. This is one of the fun part of our, hopefully you like it. So okay, let me stop here and share. Okay, hopefully you can see that. Okay, so as a reminder, this is a Cpp quiz. This is the number of the question, and the difficulty is 1 out of 3. Cpp has 17 standards. So if you have this program, what do you think would happen? It's either guaranteed to output something, so we need to put here the output, or there is a compilation error, either unspecified or implementation defined, and then the program is undefined. So take a moment to think about that. Any thought? So 2.5 would be what? So this is an overload, right? So it can take either float or double. So 2.5 would be what? What kind of a type do you think it would be?
A double.
It's a double. Yeah. So it's going to be 2. And then we say it's a float, right? We have this literal here. So it's be 1. Okay. Type of floating point literal is double. This is default one if you don't have any literal. And then you can explore it here. So that's an example of usage of Cpp Insight, and you can see that this is how it look like. It doesn't actually run it. If you want to run it, I think you can go back to Compiler Explorer, and you can say run the compiled executable, and it says 2.1. Okay. So the next one would be this question. Again, this is Cpp 17 standard. Difficulty was 1 out of 3. So we have a string stream, and then we run .str, so we get the string back, right? And then B is added to the stream, and then str. So what do you think would happen? This is kind of a tricky one. You need to know how string stream works underlying.
Will it be just AB?
Let's take a look. So first of all, A, because this is what we have, A, so A, and then B. So why? And this is the nice part of the Cpp quiz. There is a nice explanation, but and here's the explanation. kind of a nutshell. When B is written, it's overriding the A, which was previously in the buffer. You can override this behavior or change this behavior by initializing string by out 8. And then AB doesn't get overwritten. And the problem is that output A and then AB, right? Because we had A and then we added B, and we have 3 characters now. And if you look at string constructor is here, then you can see all of this stuff here. And so 8 is 6 at the end of the stream immediately after open. And the other one, what was the other one? For some reason I can't. The other one was std out. Okay, so std out would be open for writing. So these two would be enabling this kind of a pen mode, I would say. Okay, next one. Okay, same deal, Cpp 17 standard. What is the output of this program? So we have this type def. So what is this type def? What is it? What do you think it is? It's basically a function that returns an integer and accept no parameters. There's no parameters to this function. So we have this, and it looks pretty funky, but we have this func f, which looks like a member, and then we actually have definition of this function, right? So what do you think would happen here? Is this actually going to compile? Does it look sane? So one option is it is 1, right? Let's say it's a declaration here, like a prototype here, and definition here. So basically, it's pretty funny, and I think I have a blog post on Martin's blog. This was actually very interesting. I never actually seen this kind of syntax where it looks like a member, but it's actually a function declaration, and here's the definition. So it looks strange, but this is not a data member, but it's actually a function member function. Okay, next one. Okay, so this is a bit more difficult. It's the and for Cpp 17, what is the output of this program? I think we had that something similar sometime before. So we have x and y. So we need the max of these two, but the max is they are equal. So which one would be taken? So since it returns, okay. So let's take a look. So since studmax return a reference, we have a reference. So reference to what? Is it to x or to y? Same deal for minimum. We take, is it going to be a reference to x or reference to y? Then we change x, the value of x, and we change the value of y. So since these are two aliases to either x or y, we need to think about it. What happens here? Okay, so one option is max is referencing x in case of equal, and then it's going to be 11. The question is if this is true, and then what happens with mean? What happens with mean when they are equal? Which one is going to be referencing to? By the way, everything, you don't need to remember all of that stuff. If you read here, it tells you which one is being referenced. So it's somehow you need to remember this rule. if you deal with this kind of code, if you're actually holding a reference to it.
Does it just use the first one in both cases?
The first one. Okay, so if it's the first one, it would be what?
11. So it would be the reference to X.
So 11, and then
And
minimum
11 again.
and 11 again. Yeah, that's correct. So it's basically, you need to remember this. It's I honestly just have this this small info kind of burned in my mind, and I just remembered that in case of equal, it's the same. Now, if you go here, there should be okay. So the greater value of A or B, if they are equivalent, returns A, and you remember it returned by reference. So this is the mean, the max, and then the mean would be the same, by the way. The interesting part is what happens with initialize a list. The greatest value in the initialize list, if several values are equivalent to the greatest, then the leftmost one. So again, we need to remember this in order to have the correct answer. Okay. Again, Cpp 17. By the way, most of it's Cpp 17. I think they start adding Cpp 20 soon. Maybe already added some. What is the output of this program? Someone is okay. So what is the output of this program? So we have an integer I equals 0, and then we are const casting it to int reference, and then to assigning to a reference R, and then we are assigning it to 1. What does it mean here? So what would R be 1? Would R be 0? Or any other option?
This program might segfault because if it tries to dereference R, because 1 may not be a correct memory address.
So if it's segfault, so it doesn't guarantee to output anything. It's not a compilation error because you're saying it's running, but it's segfaulting. So the question is it unspecified or implementation defined, or is this an undefined behavior to const cast? And assigning, that also is another thing that added here. So I think it's undefined. It's undefined. Casting, modifying const object resulting in undefined behavior. It's from the text here, and added to modify const. So it's not the const cast probably that is undefined behavior. It's actually where you're actually touching the memory, actually deref the memory and assigning something. Then like writing to memory, which used to be const cast, is the issue here. I think reading after you const cast probably is not the issue if I read it correctly. Don't do this, by the way. The compiler might put it in some read only, and you const casting it, and bad things would happen. I don't know what happened in Compiler Explorer. Let's see what happened here. So it says 1. Let me read this. Yeah, I need to space here. Still 1. I wonder if W tell me anything about this issue. Nothing. Let's see what trunk says. I don't know whether they pick 9 point something. Trunk says 1. And let's see, trunk. Still says 1. So it seems like everyone is happy. Let's try something else here. I don't know if it's gonna make any difference. Yeah, everything still looks 1. And it is pushing to ESI, pushing one and calling the Austrian operator. Interesting. Should return 1. Yeah. You know, it looks very defined from here, but don't do it. Okay, what is the next one? Where is my PowerPoint? Okay. The last one is this snippet of code. So we have, again, Cpp 17, easy stuff. We have struct foo with a default empty constructor, not empty, sorry, just default constructor. And the constructor has C out to A, and then a copy constructor with B. So what we do here, we have foo, vector of foo of 5. The variable is bar, but we have 5 foos. What happened here? What do you think would happen?
Because it has when we assign 5, we create an empty constructor, so we cast it.
Sorry,
integer.
It's really hard for me. I don't know. Can you repeat it, please?
Actually, we have to cast integer to const to foo, so we call default constructor, and when we call default constructor, it will print A, and after that we assign our temporary foo to const foo, so it will call B. So as a result will be AB.
You're saying A and B like this?
Yeah.
Yeah, let's take it. Let's give it a try.
Oh,
Okay.
Strange.
So what does it mean to the vector? And we have the number 5 here. Let's take a look. Let's take a look at the constructor. And we're looking at the constructor with a number, with count, this one. Okay. So we have this one and we have this one, but we're actually looking at this one because this is the one with only count and everything else has a default. So it's probably this. Oh, we have also this as well. I don't know. Okay, this is from Cpp 20. So we are doing 17. So I'm going to ignore this one. I'm going to look at this. Okay, so this one is number 3. Number 3, construct a container with count copies of element with value. So the value is the default constructor. So it looks like we're gonna have 5 foos constructed. So it might be 5 A's. Let's give it a try. Okay, so why 5 A's? So it has one parameter constructor plus allocator, which is this one, which again doesn't seem like, because they said Cpp 17, right? So I don't know if this is the right one, because this one is this one. Oh, okay. So we have, so I was looking at this one, which is since Cpp 17, but we have also, this is the const expert one. So this is one option since Cpp 14 until 20. And this guy is also count. I don't know which one. Oh, this is until Cpp 7, Cpp 11. So yeah, definitely not this guy, but this one. Very hard to decipher this whole thing. Take a look what happened. The standard changed. So, but the important thing is that we have 5 foos, and they basically just generating 5 instances. The interesting part, I don't know if I can show you this, but there are cases where, let me try something. I can't guarantee that it's going to work, but I'll try. Okay, so this one would have, let's see. Yeah, we don't have vector. Technically speaking, we could say that, oh, here, I just didn't copy the vector one. Okay, so, okay, so we have 5 A's, okay, but what if we do something like this? So we start with bar, okay, and we push one, bar dot push back, and then let's say foo. So
you're compiling for C++ 2A instead of C++ 17?
Yeah, it's fine. Okay, what happened here? Why I have A and B? Okay, let's try something else. Also A and B. So why we have A and B? What do you think?
You're using the copy constructor in your use of foo. You're instantiating foo in place, and then you're using the copy constructor to add it to the vector.
Yeah, there is no elision here because there is that kind of side effect. There is no elision. Foo. So first we constructing foo. So we have A. No elision happening because there is a side effect here. But it could be elided if no side effect. The second thing that happens is that now we actually copying that to the location that we, the space that we have. Okay, let's continue. Okay, before I go ahead, how many elements? What is the capacity of this vector? What do you think? What is the size? Let's start with the size. The size is easy, right? Should be 1, right? Very simple. It's funny that it's flipped because I'm using C out and C log. It's 2 different streams. Okay, what is the capacity? Okay, let's do this. Okay, and the capacity. Capacity would be, what do you think? Let me do space. So capacity is also 1. Okay, so I would go ahead and have another pushback or in place back, doesn't matter. Okay. Do I have any typos or anything like this? Oh yeah, right. Deleted the closing curly braces. Okay, this is already confusing, right? Why do we have A, B, A, B, B? Okay, so first of all, first thing first, let's do this. Let's have everything C out or everything C log. So everything same string. Okay, so C log would be, and
Kobe, what's the difference between C-log and C-out?
Okay, so cout is std out, C-log error, std error, but like std error, but one is buffered, the C-log, C error is unbuffered. Cout also buffered. So
Okay.
C error would be unbuffered and std error. So you have error, one error, two out, one is unbuffered and two buffered. So C-log would be also kind of buffered one. Okay, so we have AB here. Then I have a new line, and then size, and then ABB. I have the capacity and the size here. So size should be 2, but capacity should be different. Okay, we'll have okay, why I pushed 1 and I'm getting ABB when I'm pushing another one? So we know that AB is just like before, right? We have a construction and then copy. But why another B? Why we have another copy? So if you think about it, we took a capacity of 1, we increase it to 2. We have a new one, so this is the AB, but we need to copy the other one. So it is another B. So if I push another one, so we have AB for the new one, but we had 2 others that used to be in the previous vector. We need to copy them. So both of them are being copied. And we can go on and on. And you basically can notice that everything that used to be in the vector need to be copied back. And the interesting part that you can see is how the vector is growing. I did not have the pushback, which is important here.
Kobe, is there a way to make the vector pre-allocate so it doesn't have to resize?
Of course. There is a reserve that you can reserve the allocation, but I don't understand why am I missing here something? Why the capacity? Oh, yeah, the capacity is still 4 because I have room. So I have 4. I'm just saying why I'm not, because I still, and this is just AB. Nothing was copied. So I had 1, and then I pushed another one, so I have 2, and then the third one I have room for 2 more. So the third and now the fourth. Now if I add another one, and yes, reserve would change that. I'll show that in a second. It's a good question. So I have another one. So now I don't have any room, so I expect to get another realloc. So if you think about, we have 4. So this AB, and then we have 4 that, so the AB is the one that I'm pushing, and then 4 that used to be before. Now I have 5. Now, going back to the question Jim had about that, is there, let's reserve 16, semicolon, so it's compiling. That's it. So we don't have this copy from the previous vector allocated to the new allocated space. It's all much more efficient. Obviously, this is the preferred approach to.
So there's no default reservation. That's
no. And you can go and take a look at the compiler documentation of the compiler. It's actually the standard library implementation. Basically, I'm usually using either libs to C++ or libs C++, the one that shipped from with Clang or the one shipped with GCC. So the stud C++ is the one shipped with GCC, though Clang can work with both of them. And you can take a look at the implementation. It will tell you the computation. I mean, it will tell you how it's going to grow the vector. So this is 1, 2, 4, and 8 different. I don't know what GCC. I can remember if GCC has the same. Let's take a look.
So objects are always copy constructed when dealing with vectors?
It's not always. It really depends if they can be moved, and there are no except. There are all kinds of special cases. There are places where it can be actually moved. Just trying to see where is the MSVC. Okay, let's take a look at what MSVC is doing. I think. Okay, let's remove this whole thing. So we don't care about it. We just want to take a look at how it's being allocated on MSVC. We need to have, by the way, we need to have a specific. It doesn't run it. That's the issue. I can show you what MSVC is doing. Is there anything? Do they have ICC? Let me see. That would be interesting to see if there is an output of ICC. ICC has the same thing. It's 1, 2. It's doubling every time. Let me see if there's anything else that I don't know if this one would be a different one. So it depends if they can run it on the servers. I bet the ARM one they don't have a virtual machine or anything like this. So I think MSVC might be different, but I don't remember from the top of my head. Okay, there is no in place back. Okay. Anyway,
with in place back, what's the difference between in place back and pushback?
So in place back is basically able to construct the object on the allocated data, unallocated space, and not constructing and then making a copy. In place back, if you look at, I already have it here. So in place back is basically a variadic. Let me see, in place here. It's a variadic one, you see. So it can actually call the constructor with the variadic arguments and construct it on the place instead of constructing and then copying or moving it. So it's much more efficient. It saves you one operation. And I know I need to have a session on, at least on vector, because this is the most common one. It's on my to-do list to do that, because there are very interesting things that are happening with vector, and I think it's the most, like it's the kind of the go-to container.
So why do we use pushback? Why is it in general that I see a lot of code?
Yeah, no, there was a, so Arthur, I'm not prepared for that, but Arthur Wire had pushback and in place back, and it's actually very recently. I'll find. Don't blindly prefer in place back. This is, I think. Okay, so this is very recent. I told you. And so this guy, I suggest just either following on Twitter, and he has, by the way, a great book. It's one of my books. He has this Cpp 17 SDL. This book, Mastering the Cpp 17 SDL, great book. Very, very good one. He's a very smart, he's from the committee, very smart engineer. I have the pleasure to meet him in person and in CppCon and attend his talks, and he has a very, very good post. Yeah, and if you read his book, he actually points out on the the things that not really working well in the standard is like, I had a discussion with him in CppCon 2019, and I told like you showing the not really working part of the standard. I said, yeah, I like to do that. So I highly recommend this book. I highly recommend, just grab it if you can. It talks about allocation and multi-threading and various containers and all the, yeah, he called it the warts, all the warts in the standard that he likes to kind of point out. So this is a good one if you can go over that. I'm just not prepared for kind of present that, but I can point you to more resources.
No, that should be enough.
Okay, so let me go back. We have about 10-15 minutes. Let me go back to share my slides and see what else I want to show you. Oh yeah, so one of the things that you can see my slide, right? When I'm flipping, hopefully.
Yeah, yeah, you're fine.
Okay, so do you see declare or define or not?
I can see it.
Okay, good. Okay, so what is declare? What is define? So there is, and the link is in the notes of the slide. Declaration versus definition. Declaration provides the basic attribute of the symbol. What is the type? What is the name? Usually, for variables, you have declaration and definition happen at the same time. It depends if you have extern, so it's a declaration, it's not the definition. Definition happens in a different place. And for functions, usually the prototype would be the declaration, definition would be the actual implementation. So just the distinction that I'm seeing people maybe sometimes kind of getting confused with. Okay, so this is something that I'm following. I don't know if it's a company or organization named Quick Step in LinkedIn, and they had this this question. Okay, so you have this animal class, and lion is derived from this from animal, and there is this variable data member type 0. Yeah,
we're not able to see.
You don't see. Okay, that's why I was. Okay.
Oh, there we go.
Okay, you see it? Okay, okay.
Yep.
Okay, awesome. Because I tell you what, I'm switching to presenter view, so I don't know if it's maintaining the share. Okay, so so I have this data member type and then a constructor. Now the question is, when I have this lion L1 10 and lion L2 without anything, what actually happens here? What do you think?
You get in the car and I'll be out in like 2 seconds. You can go in the car right now, I'll be out in like 2 seconds.
So what do you think? Give it a guess. Okay, let's have a quick. Let's see, we have time. We have time. Okay, let's give it a quick play in the.
I think the compiler will create a constructor.
Yep.
Compiler will create a constructor. Why?
It should compile.
Should compile. Yeah, it is compiling. It is creating a constructor. We're actually bringing the constructor here, right? So we have this animal constructor is actually brought in. What about this this part with no construct? No, there is no default constructor here in Lion, but it's still compiling, right?
Yeah, the compiler will create a default constructor if you don't provide one.
Exactly. So you might see it in code. You basically can bring from a base class, you can bring into your derived class all kinds of functionality. Can be constructor, can be function. The problem with using this way is that if you have an overload, they're not really a good way to bring just a single overload out of a collection. Like if I have f that takes double, f that takes integer, there is no way to say I just want the f of the integer. Once you're using whatever the base colon f, you bring everything. So that's something that you need to be aware of. One of the things that you can notice here that the using here is there is no public or private, but it's still accessible. So that's another interesting part. It is accessible. I actually thought that initially that it wouldn't be accessible, but it is accessible. Okay. So I want to point out on a new book. So I'm always on the lookout for new books in C++, and I try my best to kind of go over, at least when I have a subscription to Packet, so I can browse the book and quickly have some first impression, and if I like it, I actually going to spend some time reading it. This book I actually really liked. I'm still browsing it, but I really like what I see so far. It's first of all, it's a modern C++. Mostly there's some type def instead of using, but other than this, it's pretty modern, and it has actually all kinds of references to very up-to-date technologies like microservices and CMake and like modern CMake and things similar, cloud-related references. I really like it. I highly recommend looking at it. It talks about containers. It talks about Cpp 17, 20. Lots of good stuff. I just had an example here. You can see there is a try parse function, and there are 4 options to this to return a value. One is just returning an integer. This is something which you see a lot in C applications. Then you can see Boolean, success or failure, and then the parse number is returned. Here the parse number also returned, but -1 might be an error, or some other magic number might be an error. But what happens if -1 is actually a valid number? That's an issue. With Boolean return, you might this kind of discard. You need to have no discard in Cpp 17 and above. We just had the error handling talk, so it's kind of related. And then you have this another option where you can allocate. Don't do this, but you can allocate integer inside the try parse, and then return null pointer if it failed, or return a pointer to the whatever allocated. But there's a lot of overhead just for one integer to allocate, and then the client of this API needs to understand the contract that it needs to deallocate. And then, yeah, you can have unique pointer to transfer ownership, but it's an overhead just to allocate. Why you want to do that? And the last approach is actually, you can see that it's using string view here, just kind of parsing the string view. You can return an optional. This is, by the way, my preferred approach when I'm working with in my code base in my day job. I tend to use optional when it makes sense, and for example, here it might make sense, and then I can just return null opt, and it looks like a Boolean. You can do if on that, but if you're trying to access it, you can get an error, you can have an exception. It depends how you're accessing, but it's much more descriptive, and I can actually use any number that can be represented in integer, and it's still fine. It's not like, oh, -1 is an error, but what if -1 is a valid number? Stud optional is really cool, and I personally really like this Cpp 17 edition.
So Kobe, so are you able to not return anything at all? I mean, can you, would the compiler complain if you just exit the function with nothing returned?
You mean in which version? In the last one?
Well, yeah, in the last one, I mean, when it says that the return is optional, does it mean the return itself is optional, or
No,
returning an integer is optional?
it means that I'll show you. Where is my browser? I can't see my browser. 1 second. Oh, here it is. Okay. Let's just have minus STD equal. I think it's already default, but okay. So let's say we have a stud optional integer f. So you can return 1. Okay, let's say let's say equals 7. I wanna, it's bad. So I can have return std null opt. Okay, it doesn't mean that, oh, I don't return anything, but it means,
gotcha.
It means that there is nothing, and now doesn't matter if it's in main or not, but I can do something like auto, let's say value return f of 7. So I know that this is going to return a null opt, right?
Yeah, you need a semicolon.
Yeah, I'm just okay. So now I can do something like this. So I can do if not v, which is going to be then std clog and then so it should say nothing, which is, it's really nice, but otherwise I can return v. And this is okay. I want to return, it's going to be undefined if I try to do something. If I want to, if it's undefined, if it's a null opt and I try to deref it, it's undefined. But there is, if you look at this, it has a very rich interface. Take a look at this. There's a value or, so give me the value. If it's null opt, give me 7. Give me like a default, which is really nice. The reference here. Take a look at this. So throws nothing. The behavior is undefined if this doesn't contain a value. Okay, but what happens if you do value and there is nothing? Let's see. Okay, bad optional access if this does not contain a value. So it really depends on your code. Do you want to throw an exception if it's not there? Like blindly, you want to do that value and have an exception and maybe let the code, the calling code deal with it, or what do you want to do? It's really up to you. Do you want a fast path, no exception? I'm just going to reference it, or do you want to have value or value or? Actually, value or. Yeah, so it depends on the constructor of the return value. So that's fine because it is by value return. So very rich interface. I highly recommend using it whenever appropriate.
Yeah, thank you. This is good. I didn't know about this.
Yeah, it's really, really cool. We use it in our code base and it's very, very successful to show like a very expressive. We have a very good, a very good experience with it. What the question people might ask, okay, let me, people might ask something like this. Yeah, what's the time? I have a couple of minutes. What is the size of stud optional? And let's say v. Do I have v? I already have v. Oh, v of. Let me just take a look at what it returns. 1. Which is interesting. Let's give it a value.
I think it's because you have a return statement in the above it.
Oh, yeah. Thank you so much. 8. So it's going to be 8, right? If I have a uint 64t, let's see what's the. So I just want to show you that there is an overhead. It's not absolutely free. So there is an overhead and there is alignment here probably of the Boolean or whatever, because I think it's the size of your type and some Boolean that says there is something there. I think this is how it's implemented, my opinion at least. So this is why the size of the, because of the alignment of the biggest one. So if I have Boolean, might be 2. I don't know if it's, yeah, might be 2. So it's bool and bool. If I have a character uint, no character, sorry, 16. So it's going to be probably, so it's going to be 2 and another, so 2 and 2. It's going to be 4. So there is an overhead of the Boolean and there is alignment of the padding and all. So just bear in mind, it's not 100% free, but might be appropriate for a lot of use cases.
Hey, Kobe, can you go back to the animal lion slide?
Say it again, go back to?
The animal lion slide.
Oh, the animal. Okay, let me take a look. You found an issue? Do you see my slide?
Curious why.
Do you see my slide?
No.
You don't? Okay, let me see. It depends. Oh, because I'm not sharing it. 1 second. I'm sharing the. So I actually I wanted to have a quick. I want to have this. Okay, but let's.
Why would the second lion object be able to be initialized? The L2.
The L2, yeah, I had that. Let's give it a let's give it a shot here. Okay.
I think it shouldn't.
Okay. Class base. Just a public. We don't care about the member, right? We just have a base int. Okay. And we have it derived at public. Yeah, you might be wrong. Might be right. I prepared the slides like a long time ago. And okay, we didn't have public. We just had.
Let me send you the Godboard link so you don't have to type.
Yeah, okay, I already typing this. So thank you. So it doesn't compile for you. You're saying derived 0. So this should compile, right? Okay. What happened with the you might be right. I can't remember. Okay, so it is actually implicitly deleted. Yeah, thank you for noticing that. Next time I need to have a Godboard link. I just prepared that a long time ago. Yeah. So basically once it's like we actually define base. Like there is a constructor that takes an integer. So it's just like if I had something like this, right? So basically this would be fine. Why it's complaining. Yeah, I have a typo, right? Oh, yeah. Fine. I'm gonna do this just to satisfy the compiler. Yeah, and this is not. Thank you. Thank you for noticing that.
I mean,
Okay.
even if you add a private default constructor to base, it would still not compile.
Okay, so he's saying the following: if we had using base, and you have saying we have base.
This would work, but if you make it a private.
Oh, okay. Yeah. I understand what you're saying. Like this. Should not work. I agree. At least intuitive, it's not going to work. Well, the thing that actually was interesting is that I thought that the using needs to be like, since like if it is as if I was in private because it's class, but it didn't do anything bad. So this one still holds. This is the part that kind of surprised me.
Yeah.
Okay, so we are top of the hour, 7 p.m. Actually, I have just one slide. Like I'll have it in the next time, and obviously the books that I mentioned, the slide of the books, I'll postpone it to a different time. Thank you everyone for sticking all the way to 7 p.m. Pacific time. If you are coming from a different time zone, which has even crazier hour, thank you for being here. Was glad hosting you all, and hopefully you learned a lot of things. I do every time I have this meetup. So thank you so much. Pleasure meeting all of you. Have a good day. Take care.
Thank you.
Thank you.
Thank you.
Thank you.